That's how you do it. You pick the things that look the same. Iron plus 2 clearly goes to iron plus 3. And the dichromate goes to chromium plus 3. Those are your two half reactions. Here's a note on the half reaction issue. Here's a note on step number 2. If you ever run into a reagent that has hydrogen, oxygen, and nothing to pair it up with, in the half reaction, pair it up with water. Just no fear. Throw it in there. If you find yourself with something that has, a reagent that has oxygens and hydrogens, and you say to yourself, self, I'm at the step where I have the two half reactions that I have to write, and I don't see an obvious item on the other side. Throw it up against water. No fear. Just put that water in there. That's what you do. If you ever run across a reagent that you cannot pair up in a redox, use water to pair it up. So that's step number 2. So step number 3, it says balance the elements that are not oxygen or hydrogen. And it doesn't really make any difference which one you do first. Just because I'm here, let's just do this one first. Step number 3, the reagents that are not oxygen or hydrogen. So that would be the iron. There's one iron on each side, so I don't have to do anything. So I'm good with that, with the purple step. So in the purple step over here, Cr2O7 minus 2 and Cr plus 3, balance the elements that are not oxygen or hydrogen. So what do you think is going to happen? I have 2 in front of the Cr. Next step, number 4. Number 4 says balance the oxygens with water. And of course when it says balance, it means that you're going to put the water on the other side, of course. Because you're balancing. You can't keep adding water to the same side where you already have the majority of the water. That's not balancing. So number 4, I still don't do anything here because I still don't have any actionable step. So far I haven't been able to do anything to that. But this one over here, I think I'm going to be a little busier. So Cr2O7 minus 2 going to 2 Cr plus 3 plus how many? 7 waters. Balance the oxygens with water. Number 5. Balance the H's with H plus. Number 5. Still, diddly squat. Haven't done anything to this one yet. Fine. Balance the H's with H plus. What do you got? Don't forget to turn your cell phones off, please. Balance the H's with H plus by adding the H pluses to the other side, right? So far I got Cr2O7 minus 2 going to 2 Cr plus 3 plus 7 water. And what do you got? 14. To the other side, right? 14 H plus to the other side. Be methodical, pay attention to details, and pick up speed. As we do more of them, we'll pick up a lot more speed. Because I have 7 oxygens, and the step says balance oxygens with, what are you going to do here? 2 Cr plus 3 plus 7 waters. What are the charges on either side? What's the charge here? Try again. 6. Because there's 2 CR plus 3s. That's our remedial math. What's the charge on this side? No, mommy, plus 14. Okay, plus 14. Charges? Charges? That's a charge. That's a charge. What's the total number of charges on this side?
12.
Not just 12, it's plus 12. And in Redox, don't forget that you absolutely have to say the plus and the minus. Why? Because you have 14 pluses and 2 minuses. Do we agree? Okay. What do you do?
Take the electrons on the left side.
Where do the electrons go? On the more positive side. That's this one?
No.
Of course not. It's this one. And how many are you going to add? 6. You guys don't need it. And finally, cross multiply and recombine. Cross multiply and recombine. Cross multiply. Because I need, for that step, to have the same charge on both sides of the equation. And right now, as it is, I had a plus 12 because I had a 14 plus and a 2 minus, so that's a plus 12. And on this side, I have 2 CRs plus 3, so that's a plus 6 total. The electrons go on the more positive side. Because now, a 6 minus and a 12 plus gives me what? Say 6 plus, which is the same as the other side. Good. Cross multiply and add. The purpose of step number 7, this one down here, is to acknowledge that redox occurs in a pair of reactions. One in which an oxidation takes place and one in which a reduction takes place. Which of the 2 half reactions is the reduction and which one is the oxidation? What's this, an oxidation or a reduction? How do you know? How do you know it's gaining electrons? How do you know it's gaining electrons?
It went from
Because you are picking them up. It shows it in the half reaction. How do you know that's an oxidation? You're losing electrons, you're giving them away. You're producing electrons. Of course that's the oxidation. That's the definition of an oxidation. So in this reaction, once you get to this step, you can clearly see the oxidation and the reduction. This one being the oxidation, this one picking up the electrons as starting materials. He's going to eat them up. That's the reduction. Are we clear on that point? Sure? The second thing that is absolutely true, other than this being the oxidation, that being the reduction, meaning that the iron is going to spend his entire time flicking electrons at the dichromate. And the dichromate is going to have to pick them up. Right? Because that's the oxidation, and this was the reduction. And those are the roles they play in this particular redox equation. Another thing that's true is that law of conservation of mass and matter and energy and all that. Right? You know, my oxidation right now is producing 1 electron at a time. My reduction is consuming 6. You know that can't happen. I have to represent the process in a way that reflects reality. And the reality will be that the oxidation is going to produce the same number of electrons as the consumption of the electrons in the reduction. The cross multiply and add is just so that the electrons are the same number. What would you do to this equation, or this one, or both, to have the electrons be the same number? To me, all I have to do is multiply that one by 6. That's the cross multiply and add thing. Let's finish it off and start the process again with a new equation. Here we go. So now I have 6 going to 6 Fe plus 3 plus 6 electrons. As you practice redox and you begin to do your own exercises over and over and over, you're going to run into your own mistakes. Every one of you is going to have a slightly different tendency to screw up in a different step. And you will learn that about yourself. And you will learn to look for that mistake as you move on. My case, my mistake is this one. This one here. When I go through these really fast, my mistake is that I mentally forget to multiply the second item. So when I distribute that 6, I end up not writing it. So from that point on, I'm screwed. Because there's no way that from that point on, when I carry the reactions down, I'm ever going to be right from that point on. And redox is like that. It's tedious, but you got to pay attention to detail and pick up speed. So be aware of your own mistakes and double check that you're multiplying across. And now the other one, I leave it the same, right? So I got 6 electrons plus 14 H pluses plus Cr2O7 minus 2 that I never had a coefficient for. And I check these things. And I wrote that charge, and that's a plus, that's a minus, plus, and I check everything. Going to 2 Cr plus 3 plus 7 waters, and that's it. Did I get everything? I wrote everything on the left and on the right. Okay. This is balancing redox, where you cancel the same number of electrons on opposite sides. If you ever get to this point and you have the electrons on the same side, rip it apart and start again. Don't try to correct your own redox. When you screw up a redox, don't look at the one you just did. Tear the page out, because you're going to tend to see the same mistake and you'll never pick it up. Start it from the beginning. Whenever you screw up a redox, don't look at it. Turn the page over, start it again. And pay attention to detail. And now, here we go. Net 6 Fe plus 2 plus 14 H pluses plus Cr2O7 minus 2 going to 6 Fe plus 3 plus 2 Cr plus 3 plus 7 H2O. And that's your balanced redox. This has a name. It's called balancing in what's called acidic medium. Balancing in acidic medium.